Hello and welcome back to Mikey's Flightdeck. In this video I will show you how you can build this ADF panel for your Boeing 737 pedestal. You will need the top, middle and bottom plate of the panel, as well as a black push button, a dual rotary encoder and two small on-off switches. The two switches that I'm using here are in my version on-off switches. So they switch from one mode to the other, ADF or antenna. Prosim has built in another switch type, a 3-position switch, which is on-off-on, which changes from antenna to off and then to ADF. To be compatible with this setup on the hardware side, I would need here two wires connected to the switch, which would be possible because it is an on switch here and not an on-off switch, which you can see when you look at the switch. There are 3 pins in the back. But if I would use it as an on switch, which is possible on the hardware side, because when you're looking at the back there are 3 pins visible, then this would cost me 4 extra pins on the Arduino. I only want to invest 1 pin per switch here, and we will come out with a solution on the configuration side later in MobiFlight to make this possible. The ADF panel is a little bit different than the COM or navigation panel. These panels have only 7-segment displays at the top, but the ADF panel has, beside these 7-segment displays, 2, I would call this annunciators, which gives you an information if the panel is in the antenna or ADF mode. So there are 2 tiny labels that become illuminated. The normal LEDs I would use for those purposes are too big to fit in these places, and so this is the first time that I'm using SMD components. I have bought some SMD LEDs and will now try to solder them onto the PCB. So here we have the fields where these SMD LEDs will be mounted, and I will get out 2 of them here from the holder. There they are. There is a little green dot on one side here, which will show me that this will be the ground pin here. So this will be the orientation how I will mount the LEDs later here. And now I will apply solder on one pad here first. The reason why I'm mounting the LEDs at first is that now I'm able to reach here without any interfering objects here. So now applying a little bit of solder to this pad and to this pad. And now I'm holding the LED in place while I'm heating up the solder again. That's it, it's already in place. Same with the other LED. There it is. And now I'm turning the board around and applying solder to the other side.
1 and 2. Let's see if they have survived the soldering. Yeah, one LED is lighting up and the other one too.
Now I have discovered a design mistake that I have made. It came in my mind that the LEDs for the active and the standby side are controlled individually. So that would mean that the standby side could be in the ADF mode and the active side in the antenna mode, which wouldn't make any sense. So the corresponding LEDs, the two ADF or the two antenna LEDs, are illuminated at the same time. So I don't need a pin for each of them. Meanwhile, there is a function in MobiFlight with which you can activate multiple pins with just one command. This could be an option here. I just would have to connect all the LEDs here with a separate cable, but this would cost me 2 pins on the Arduino. This isn't a big hardware problem, and I have decided to solve it by just bridging the two LEDs with a wire on the back of the PCB. To prevent the LEDs from spreading their lights everywhere and maybe illuminate the wrong label, I have designed a 3D printed box with 2 chambers where these labels are fitted in. I have already made experiences with spreading lights when you remember when I made the after overhead panel, and so this time I started directly with 2 separate chambers for the labels. Now, when the panel is built together, we can go to the configuration. But before we do this, we have to talk about how the panel is made in Prosim. You can see this here. I've opened this in the corner of the screen. Only the 2 active frequencies are shown. Most panel builders are making the panel like I have done this. 2 separated panels, ADF1 and ADF2, with the active and standby frequency. Here we see something like a merged panel of these both. I haven't seen such a version at professional manufacturers. And so we have to keep in mind that we always see the active frequency and we have to look up the standby frequency somewhere else. Now let's come to the configuration in Prosim. You go again here at Config, Configuration, and to the Combine Config tab. And here again use the search function, in our case ADF1, and you can see the configuration is done here in the navigation category. And when we open this, we will first have a look at switches. And here I have already inserted the offsets we are using. The ADF mode switch antenna and ADF. I will talk about this in short. And we have the ADF tone on here. And down here we have the transfer button. In my last video about the navigation panel, I have shown you that we have used the standard FSU IPC offset for the transfer button. This ADF panel isn't there in the configuration in FSU IPC, and so we have to use an individual offset here. Some words about the ADF mode switch here. You can see in Prosim it is a three-way switch. So we have ADF, antenna, and off. In my panel I have built in an on-off switch only, and so we don't have the mode switch off, and I have assigned an offset to antenna and ADF. In other cases, when we have an on-off switch, I only assign an offset to the on state. But if we would do this and assign only an offset for the example, the antenna mode, then there wouldn't be a possibility to say Prosim that it should switch to the ADF mode now, because it isn't clear that only if antenna isn't the mode selected, then it is automatically ADF. It could also be off. And so we will use an offset for both of these states here for a clear communication. In the numerical category, I have assigned an offset to the standby frequency. Again, you have seen this in my last video about the navigation panel, that I used the FSU IPC offsets that are already there. And so it is here for the active frequency of the ADF panel. Let's have a look here to the FSU IPC documentation. Let's search for ADF1. So here we can see we have an offset for the active ADF1 frequency. Like at the navigation panel, a number of 1234.5 is transmitted like 234. So the leading one is assumed, and we have to add this later with some calculations. So this is the first part of the frequency, and the extended ADF1 frequency, you can see this down here via another offset, and there are the values behind the decimal point. And some more informations, we will come to this later. But when we now search for the standby frequency, you can see this here. It is built like the active frequency, but I have tested this when you use these two offsets, not the value comes over to MobiFlight like it is in a simulator or in a Prosim. And there is another problem. You can see this here at the end of this table. It is not possible to write into this offset. So even if we could read out the offset, when we change the encoder, we wouldn't be able to write the new value into this offset here. So this value isn't useful for us, and this is the reason why I have assigned here an individual offset for the standby frequency we can work with. And the last thing down here, the encoders. This time, because we aren't able to write into the offset of the standby frequency, we will use the internal function here of Prosim and write the state of the encoders. And when we give the signal that the encoder should turn, then Prosim is changing the standby frequency. So I have assigned the inner shaft and the outer shaft with a 16-bit signed offset. Now let's come to the configuration in MobiFlight. But before we do this, let me say that if you are new to this configuration topic, then watch my dedicated video about configuration in MobiFlight and Prosim, where I go into every step here in detail. I will assign different names for the configurations, and for not irritating you too much, these names will come from these numbers here I'm assigning. Everything is connected to my Arduino J, and so everything starts with a J here. You can see the outer and inner shaft has two configuration numbers here because it has two cables going to the encoder, and all the other devices we will configure are here. You can see here I haven't assigned a pin on the Arduino to the switch mode antenna, and this is because I haven't connected a cable to it. I have said this before. Let's have a quick look to the devices in MobiFlight. You can click here to MobiFlight modules, and I have connected my Arduino J, where we find, beginning from J07, all the devices I have declared here. 07 to 08, these are the encoders. I'm using the two numbers so I know the encoder uses these two cables. Same for the inner shaft here. Then there are the 3 buttons and the 7-segment display. And of course we have the 2 lights, the LEDs, for the ADF or antenna mode. The ADF tone mode switch is just a normal button with an on press and on release state here, J13, and under J14 I have assigned a configuration for the transfer button, again with an on press and on release state. You will know how to make those configurations already. Now let's make a configuration for the encoders. I will call this J07 to 08 for the outer shaft, and it will be the module Arduino J, and J07 to 08, which is my encoder. The action type is an FSU IPC offset, and I'm entering the offset I have chosen for this here. And this is 5328. The size is 2 bytes. So, and now we are looking to the left turning configuration. So when I turn the encoder to the left, then I want to reduce my value by 1. And we don't have to enter all these values again on the other tabs here. We can use the copy function, and when I then go to the on left fast tab, I can just press paste. Everything is inserted, and I just have to edit here the set value. And when we go left fast, we want to reduce it by 10. And this is again a good example how near MobiFlight is to all the users. I often thought, how cool would it be when I could have a button here or copy this site, because I have to insert everything again and again, and there it is. So the software is still developing. So next page, and here we don't reduce the value on the right, but we will add 1. And on write fast, we will add 10. So that's it for this configuration. And now we duplicate this configuration and call it 09 to 10 for the inner shaft. And I will assign an offset. So this offset will be 532A. Everything else stays the same. So we just click copy and insert this here and just edit the set value. And on write fast. That's it for the inner configuration. Let's come to the configuration of the standby display, which I think will be the easiest one of the two displays here. Let's go over to the output tab here and let's make a configuration J15 to 17, which are the 3 pins which control the max chips here. There it is. And we will use an FSU IPC offset here. The offset I have assigned is 532C. So this is a starting offset and the size is 2 bytes. And let's go to the display tab. The module is Arduino J and the type is a display module. The name is already assigned and it is the second display here. We have 5 digits here and we will use all 5 displays. And the decimal point is on the 4th segment. So let's make a test here. And you can see 1, 2, 3, 4, 5 and the decimal point, well, you can't see this there, are lighting up. You may ask yourself, why have I used white 7-segment displays in my last video and now they are red? And this is because I got aware that I always have planned to use red LEDs and only soldered in the wrong one. And so here I have done the right soldering. These are red 7-segment displays and I will change all the other segments that are still white to red 7-segment displays. So I only use red displays in the pedestal. And now we do a configuration for the active display here. And to do this, we have to add some more configurations here because you have seen we have 2 different offsets that are combined, are building the active standby frequency. And so we have to read in these 2 offsets first. So I will make a configuration that is called ADF 1, which is the first part of the frequency. And I'm using the FSU IPC offset and the offset which we have seen in the documentation before. And this is 034C, 2 bytes long. And it is in binary coded decimal format. I see. I'm always giving those configuration the extension var because so I'm aware of the fact that this is a configuration I am using in other configurations. So, and now I duplicate the row and call this ADF1 2 for the second part of the frequency. And here I'm also inserting the offset 0356. The rest is the same. And when I now click run in MobiFlight here, I have the simulator running in the background, so it will connect.
Then here we can see the frequencies are already coming. ADF1, the first part of the active frequency is 284, and this is right here. And the second part behind the decimal point is 0. And here you can see the 0 is coming. Here we can still make use of the rotary encoder here. And you can see when I'm turning it and changing the values are changing here as well. And when I'm going to a high value with 1 at the beginning, then you can see our second value here is changing to a value above 100. So this will be important in a moment when we are talking about the formula to show this up here in the display. Let's come now to the configuration of the active frequency. Something I have forgotten to show you is the naming of our standby frequency configuration has the appendix 2, so 15 to 17 2 for the standby frequency. And when we duplicate this row now, then the beginning is the same, but the extension is a 1 for the first, so the active frequency. And in this configuration, we don't need an offset here, so we can just zero it out. But we will make references on the two configuration we have done before. So I add the reference and I can choose it here. Down there we find the second configuration that we have done. We will use this and we will add the second one, which is ADF1. We will use this too. And here you can see the symbols, the hashtag and the exclamation mark that are used as a reference for these two configurations. And now we will use the two configurations in a transformation. And we'll have to look at the value of our second value here, which gives us information about the value behind the decimal point, but also if it is a value higher or lower than 1000 in total here. You can see if the leading one should be visible or not. So let's start here. If hashtag, our second value, is bigger or equal 100. This means we have to show the leading one. Then now we have to do something with the two values. We will multiply our exclamation mark value, which are the first 3 digits here, by 10. So you remember, in this case here, 674 would come here to MobiFlight, but to move it one segment to the left, we have to multiply it by 10. So here will a 0 be added behind this value. Now we add the next value to our frequency, and this time we'll look at the number behind the decimal point. Hashtag modulo 100. You know the modulo operator already. This divides the number through the value we are giving here, 100, and the rest is given as a result. So when we have the value 105 in our second value, then we know, first of all, it is bigger or equal than 100, so we have to show the leading one, and 5 from the 105 is the value that we have to show behind the decimal point here. And so when we make a modulo operation of 100 with 105, then the result will be 5. And this is what we have to add to our value now. So the 5 will be added to the end of this number. And now, remember, we are still here in the case when we are higher or equal 100 for the second value. We have to add the leading 1 in front of our value here. And this is done by just adding 10,000 to our value. Else, if we are lower 100, so we don't have a leading 1, everything else is the same, then we will multiply our exclamation mark by 10 and add the hashtag value, because then the value we get is already the value that we have to set behind the decimal point. On the display tab, nearly the same configuration, but this time we are talking about the number 1 here, and the rest stays the same. Let's test this. 1, 2, 3, 4, 5, and the decimal point at the right position. Everything works. And when we now click run, then we can see the active frequency is also the active frequency here on our display. And turning the encoder here changes the value too. To check if the standby frequency matches the frequency in Prosim, you can go here to the navigation tab, and down here in the list we find the radio standby frequency ADF 1, which should be at the moment 3701. And when we now look here to our display, then you can see that the 1, which should be the last number here, is in front of the decimal point. So there is something wrong here. And let's have a look to our display configuration for the second display. And here we can see we should use the padding. So the numbers are filled with zeros from the back and go to the left, but it should be aligned to the right. And when we use the left padding with zeros, then you can see it goes to the right and the 1 is behind the decimal point. I think we should edit this at the active frequency too. So use left padding. Okay. And when we now use the encoder, you can see we are increasing the numbers at the end of our value, and with the outer shaft here we are increasing the higher numbers. Let's go down so that we see a leading 1, more and more. There it is, the leading 1. And now use the transfer button. So to make it a little bit easier, 1700.7 is the standby frequency, and this switches over to the active frequency and the other way around. So transfer button, encoders, displays are working. Let's now come to the ADF and antenna switch. Back here on the input tab, I will make a new configuration for a button, J11, which is the number of the ADF configuration of this button. The module is the Arduino J and the device J11. And now I'm not making a normal button configuration, but as an action type, I will use a MobiFlight variable. because I want to store the state of the button and then use it in another configuration. So I will give the variable the name J11 on press. So in this case, my switch is in the ADF position. Then the value is 1. Again, I can copy here. Very cool. And the on release state. So my switch is off or in the antenna position. Then it is 0. I'm simulating a button now with this variable J11. And now go over to the output tab. And again, I'm making a new configuration, J11. This time, I'm not using here the FSUIPC offset, but the MobiFlight variable, which I have made, J11. And now I go over to the display tab. And I don't give out anything to show, not an output device, but I will do an input action. And I will use on press, on release. This action you can only use with variables that have the value 1 or 0, which we have made sure before. So I can use this. And as an action type this time, I will use the FSUIPC offset here. So on press, my switch is in the ADF position. Now I will use the offset I have inserted in Prosim 5320, and the bit is the 0 bit. And I set the value 1. So I'm now in the ADF mode. Copy and on release. So my switch is not in the ADF mode anymore. Then the offset is the same, but the value is 0. Let's duplicate this row and call it J12. We are again looking to the variable J11, but this time we will have to do a transformation with it, because now we are looking from the perspective of the antenna mode. And if this variable has the value 1, then the antenna mode is not activated because the switch is in the ADF mode. So we have to invert our value here now. So we will make a transformation if our value is 1, then it is 0. Otherwise it is 1. So now we turn around the value every time. Go to the display tab here. Again, an input action with the on press and on release state, but this time with the offset for the antenna mode. This is the same, but the byte is a 2 byte. So copy, paste, and here is the 0. So this should work. Let's test it. In Prosim displays, this button isn't animated, so we don't have a reference where this is turned to. So we can again look to the navigation tab here, and at the first entry we have the ADF mode switch, which is on ADF at the moment, and this matches the state here of our switch, which is in the ADF mode. Now turn it down to antenna, and the switch mode is changing to antenna and back to ADF. Oh, this is working. Last thing now, the 2 lights that should light up here. We will do a configuration now. The 2 LEDs are also simulated by Prosim. We could light these lights up here just by looking to our switch we have configured right now. But I think if the light is has a failure or something, a simulated failure, then I think Prosim should control this. So I have added 2 offsets here in our navigation category under indicators. There we find these 2 LEDs, ADF and antenna, and I have assigned these 2 offsets here. So now in MobiFlight, in the output tab, I make a new configuration, J18, and I'm using this offset here, 5320, and the 6-bit to display it in our output device, Arduino J, a pin, and it is J18. Now let's duplicate this configuration, call it J19 for the antenna mode, J19 is a pin, and the variable we have just to change the bit here to the 7-bit. So this should be all. Let's test it. I have already running MobiFlight now, and our switch down here is in the antenna mode, and you can see on both sides the antenna lights are lighted up, and when I go to ADF, they go up. The ADF LEDs are lighting up. So this is working, and this means the whole ADF panel is finally working.
And here are the 2 panels in place. Nice to see that more and more panels are finding their way here now into the pedestal. And it was a good example that even if you look up all the documentations, you still can be faced with problems you have to find a solution for. In this case, I have shown you a way how you can connect these panels to the simulator via Prosim and MobiFlight, so you can save a lot of time. And you can save even more time if you become a member of my website, where you will find all the needed files to cut out and engrave or 3D print those panels and all the knobs and switches here. So I have to move on now to the next panel section, and if you don't want to miss this upcoming episode, then subscribe to my channel to stay informed about any upcoming new video from me. So I hope we'll see us soon back on the flight deck.